Hi everyone, and welcome to this video going over special parallelograms with some extra practice problems. Let's get started. In number 1, it says that ABCD is a rhombus. And so something I did for this video is I put a copy of the last 3 columns or the last 3 rows in the chart so that we can practice using this chart to help us mark our pictures. So I'm looking at the rhombus row. I know that the opposite sides are parallel, they're congruent, that the opposite angles are congruent, and that the consecutive angles are supplementary. So looking at my rhombus, if I want to find out what x is, I know that 104 degrees and the x are consecutive angles because they are right next to each other. And according to my chart, in a rhombus, the consecutive angles are supplementary because they're same side interior. So I know that 104 plus x has to equal 180. So I'm going to subtract 104 to both sides. This will give me 76 degrees for x. For the other part of the problem, they give me 2 side lengths. Let's scroll down to our chart and see what we know about the sides of a rhombus. According to my chart, a rhombus has 4 congruent sides. So no matter what side lengths they give me, I know that they're all equal. So I can set these 2 side lengths equal to one another. So 3y equals the y plus 8. Because all of the sides of a rhombus are the same. I'm going to subtract y to both sides. 2y will equal 8. And by dividing by 2, I get that y is equal to 4. Let's try another special parallelogram. In number 2, I have a square. A square is pretty simple because I know that all of the angles are right angles, meaning they all measure 90 degrees. And I know that the diagonals bisect all of the angles, so I know that each individual half is 45 degrees. This will always be true for a square. So I know that angle 10 is 45 degrees. In order to solve for x, I can say that 5x equals 45. If I divide by 5, I get that x is equal to 9. And we can check to make sure that this is right. If I plug in 9 over here, I should still get 45. 3 times 9 is 27, plus 18 does get me the 45 degrees. And we can do the same thing with this 2y. 2y should equal 45. If I divide by 2, I get that y will be 22.5. So make a note, if you ever get a square, you know that every angle will be a right angle, and so that each individual half will be 45 degrees. Now let's try a rectangle. In number 4, it says that QRST is a rectangle. I am given one angle measure, and they want me to fill in all the rest of the angle measures. So scrolling down to my chart, I want to see what's true for rectangles. A rectangle has opposite sides parallel, opposite sides congruent, opposite angles congruent, the diagonals bisect each other, consecutive angles are supplementary, and 4 right angles. This is probably the big one. So let's go and make sure that we know that all of the angles are right angles. If angle T needs to be a right angle, I know that in total it needs to be 90 degrees. So in order to get the other side of angle T, I'm going to subtract 34 from angle T, or subtract 34 from 90. And I get 56 degrees. Also, something to note about a rectangle. Because the sides are parallel, I can look for alternate interior angles. For example, if this angle is 34 degrees, then this angle will be 34 degrees because of alternate interior angles. Similarly, if this angle is 56 degrees, I know that its alternate interior angle is 56 degrees. Also, something important for rectangles are that the diagonals are congruent. So if the diagonals are congruent, then I know that each of these lines are congruent. And if you notice, I have a bunch of isosceles triangles. In an isosceles triangle, the base angles are congruent. So if this angle is 34 degrees, I have 34 degrees here. Similarly, 56 degrees and 56 degrees, 34 degrees and 34 degrees, and 56 degrees and 56 degrees. Lastly, because I have all of these triangles, I know that a triangle, all the angles need to add up to 180 degrees. So if you notice, I have 2 angles for each triangle, which means if I subtract 56 and 56 from 180, I can get their missing measure. So 180 minus 56 minus 56. Will get me 68 degrees. And so I know that this angle is 68 degrees. And because of vertical angles, this angle must also be 68 degrees. And then I can do the same thing with my other triangles. 180 minus 34 minus 34 gets me 112 degrees. So I know it's a lot to remember, but this pattern will always be true for rectangles, no matter which rectangle you are given, or no matter what rectangle you are given. I'm always going to create isosceles triangles, which means the base angles will always be congruent, and the sides will always be parallel, meaning the alternate interior angles will always be the same. Let's try another rhombus. ABCD is a rhombus. They want me to find angle 8 and angle 6. For a rhombus, something really important to remember is that all of the angles are being bisected. So each half of each angle is congruent. So if this side is 53, then the other side is also 53. I also know that the opposite angles are congruent in a rhombus. So if A is 53 and 53, then C is going to be 53 and 53 as well. Which means that angle 6 is 53 degrees. To get angle 8, I need to find out what this half of D is going to be. Well, I know that angle D plus angle C needs to add up to 180 degrees because consecutive angles for a rhombus are supplementary. So what I can do is I can say 180 minus 53 minus 53 will tell me what angle D is supposed to be. If I do that, I get 74 degrees, which means all of angle D needs to be 74 degrees. But I know that D is being bisected, so I have to divide 74 by 2 to find out what each half is. And this gives me 37 degrees. I also could have known that the diagonals of a rhombus are perpendicular, meaning this angle right here is 90 degrees. And in order to have a triangle, all of my angles need to add up to 180 degrees. So I also could have said 180 minus 53 and minus 90. Which also would have given me my 37 degrees. So I hope that these 4 practice problems helped you feel a little bit more comfortable with special parallelograms. If you'd like to see more, just let me know. And I hope that now that we have a spreadsheet with all of the properties, that we can start to use that to label our picture and apply our properties better. Please let me know if you have any questions or need more help, and I will see you in class.